Welcome to our first and only Quit Cheering podcast of this unit, Unit 6. We're at the top of page 5, and we're going to actually kind of go backwards from all of the work we were doing earlier in your class after the test. What if I only knew the percent composition? Can I figure out what its formula was? And the answer is yes. So first, find some place at the top there. What is an empirical formula? It is the simplest whole number ratio of the atoms. Okay, this is important. Whole number, okay? Also, it's the simplest ratio because it's going to be different from what we're going to look at a little bit in class, that you can actually have a multiple of this, and that's going to be its true formula, which is the molecular formula. So this is its simplest formula. And when we're looking at this, we're going to use percent composition. So you're going to go from a percentage to a formula. What we did when we first started this unit, we went from a formula to a percentage. So we're just going to work it backwards. Notice what we need here. We need a ratio of moles, not masses. I can hear you cheering now. So the math isn't really as bad because we have steps that we're going to go through. So there's you have space at the top. Let's go through this. And again, you need to write as much as you need to be able to remember how to do this. Step 1, you're going to convert percentages to grams. Okay, this is the easiest way to do this if you have 100 grams of a compound. So for instance, if I had something that was 15% sodium, it was 50% chlorine, and it was 35% oxygen. This doesn't exist, I just made these up. What would I do? Well, if I had a 100-gram sample, you would say, oh, 15 grams is sodium, 50 grams is chlorine, and 35 grams is oxygen. So you just change the percentage sign to a gram, but this is the reason you can do that. If you already are given grams, you don't have to worry about that. Okay, grams are worthless. So you're going to have to use molar masses to go from grams to moles. Okay, the conversion. What you're given will always be your grams. So the conversion is always going to be the same when you're going from grams to moles. You want moles, you're going to use the molar mass, and so then you would just use the grams on bottom. That's the molar mass. You're going to get very comfortable with doing mole calculations by the time we are done with this. Here's another hint. Don't round. If you round, it doesn't work as nice and neatly and you get frustrated. So go ahead and write down more numbers than you need, because you can always, we actually don't use those numbers. So don't round. Again, it's a hint. Okay, step number 4. Divide. I don't know what happened to 3. Okay, just checking. Okay, so once you have all of that, step 3, you can actually call it step 3, you're going to, once you have all your mole values, divide all of those values by the smallest. The reason for this, we need to get at least 1 to a whole number. If, this is really important, if all of your answers are within 1/10 of a whole number, then you can round. Okay, if it is not, then you have to do a little bit more of a manipulating. And so if you get a number that's divided by, or excuse me, that ends in a 0.5, 1.5, 2.5, think halves. This is like 3 halves, 5 halves. Think of the reciprocal. You would multiply all of these by 2. If you get something that ends in 0.33 or 0.66, those are thirds or 2/3. But again, reciprocal would be 3. 0.25 or 0.75 quarters. That's why you would multiply it by the 4th. And again, it says etc. Really, these are the only ones you're going to see. Okay, all of these steps are going to make sense once we start doing it. But the nice thing that you like about this math, you can go back and you have a pattern. And it's just a little bit easier when you can always say, step 1, do this, step 2, do this. Okay, so you know what? Let's just do some. Step 1, what did we say? Change percentage to mass. This is how it's going to look. It says find the empirical formula, and look at what it gave me. 53.7 grams of iron and 46 53.3 grams of sulfur. Okay, step 1. Well, I don't have a percentage, so you don't even have to do that. Now I'm going to kind of model the best way to write these to keep yourself nice and straight. So you have iron and you have sulfur. Make yourself kind of do it kind of linear. You have 53.7 grams of iron and you have 46.3 grams of sulfur, because we can start working these at the same time. Okay, so our next step, 3-4, step 2, get to moles. So look up the periodic table. Oh yeah, you need your periodic tables. Molar mass of iron. So 1 mole of iron, this is from the periodic table, 55.845 grams. Okay, before I pick up my calculator, I'm just going to do the setup so I can do my math all at once. So 1 mole of sulfur, again, this number comes from the periodic table. Okay, now I'll get my calculator. So when I do the math, 0.96159, I don't care about significant figures. I'm giving myself a lot of numbers. 1.44389 moles. Okay. Now, in theory, notice in theory, we could stop right here and say, okay, this means my ratio is iron of 0.96159 to every 1.44389 moles, because that's what it is. Okay, that's just really not convenient. So what we need to do is get to whole numbers. So this is where our next step, 4-3, came from. Divide them both by the smallest. So look at these two numbers. Which one's smaller? 0.96159 is smaller. We know that's going to get us to 1 at least. We're going to get one of our numbers to a whole number. Okay, definitely with these, what you do to one thing, you have to do to everything to keep them in the same ratio. So you do that math, okay, and so here's my ratio. It's a 1 to a 1.5. Okay, here's that problem. It said if I was at within a tenth of a whole number. This one is good. Okay, this one is not good. So this is where that next step came in. This is like a half. So how do you get rid of a half? Multiply both numbers, because again, what you do to one, you have to do to everything. Keep them in the same ratio. So that's a 2. This is a 3. So we know Fe2S3. Oh, hey, we could even go further. Say, okay, name this. This is iron 3 sulfide. Because we know iron could be either an iron 2 or an iron 3, and from this we figured out this was iron 3 sulfide. Okay, so it's kind of cool. From the masses, you can figure out its formula. Okay, let's do another one. So look at what we have this time. I have sodium. Okay, I'm going to list them out the same. So I know I have sodium, I have sulfur, and I have oxygen as I'm going through this. Okay, so here's that first step. If I have a percentage, which I do, change them to grams. How? We're assuming it, but you know what? Just change the sign, because we are assuming we had a 100-gram sample. 44.99 grams. Okay, next step. We don't like grams. They're awesome in the lab. They don't do us a lot of good when we're trying to do chemistry calculations. So from the periodic table, I'm getting the molar masses. Okay, 1 mole of sulfur. This is where you just will start to learn the masses. Some of you said, do I know them all, or do Mrs. Brolin and I know them all? No, we just use some of them so many times that they just kind of get stuck in my head. Okay, now pick up your calculator. 32.38 divided by 22.490. 4084 moles. Okay, 22.65, divided by 32.066, 0.7064 moles. And then 44.99 divided by 15.99, you get 2.812 moles. Okay, again, not whole numbers. Divide them all by the smallest. So these all get divided by the smallest. So look at these three numbers. This is your smallest. So you're going to divide them all by the smallest, 0.7064, 0.7064, 7064. So we know this one gets to 1. Okay, this one on my calculator is close enough. It's within the 10th, so I'm going to round it to 2. This one on the calculator, again, close enough. I can round it to 4. So look at, you have the whole number, so we don't need that step 5 here because they were all close enough that we could round. So your formula would be Na2SO4. Let's practice. How'd you do on that test? This is sodium sulfate. So again, from a percent, because we know the composition doesn't change for the compounds, you can get the formula. So look at the next one. Look what you have. Carbon, hydrogen, oxygen. Okay, that's all I'm doing. The rest is up to you guys. And we will go over that at the beginning of the class. And hopefully you didn't think it was that bad. That oxymoron is actually kind of fun math. We will see you on our next day.